Hi there. KEAM exam 2022 was conducted on 4th of June, Monday. And here we are going through a fast verification of the answers of the questions. I haven't written the questions there, only the answers. I will read the question and we'll go through the answers. I have opted version 4. Version 4 is with me. We will go through the questions. The 73rd first question in chemistry, 73rd question. The product formed when benzene diazonium fluoroborate is heated with aqueous sodium nitrite in the presence of copper. This is a straightforward question from the textbook, isn't it? We know when benzene diazonium fluoroborate is heated with aqueous sodium nitrate in the presence of copper as catalyst, we get nitrobenzene as the main product. Side products are the nitrogen gas evolved, boron trifluoride and sodium fluoride. So in that question, the answer is an easy one. It is nitrobenzene, option given as E there. Okay. The next question. Which of the following is a polysaccharide? Polysaccharide, and the options are glycogen, lactose, maltose, sucrose, glucose. Here we know glycogen alone is a polysaccharide. It is known as animal starch, isn't it? Whereas lactose, maltose, sucrose are disaccharides and glucose is a monosaccharide. So it is an easy answer. 74 for the question 74, it is glycogen. 75th question. Which of the following is added to commercial salt to control hypothyroidism? We know hypothyroidism is resulted from iodine deficiency, and so we have to supplement iodide by adding either sodium iodide or potassium iodide in a very small quantity to the edible sodium chloride. Okay, so actually it can be either sodium iodide, potassium iodide, even sodium iodate or potassium iodate can be added. But here they have given sodium iodide and potassium iodide along with other options. And they have chosen sodium iodide as the answer, not potassium iodide. Actually, it is a thing that is questionable. There are two options in the given question. Those who make for additional elaborate study will find both are acceptable. So, you may, if you have gone wrong by choosing B as the answer, they may question the validity of this question because they have provided two answers. You can definitely question that. Okay. Given answer is C, sodium amide. Even in commercial samples, either these can be used. They are both costly. So, you cannot say sodium iodide being cheaper that is used because their price difference is not very much. Okay, both are costly. Okay, and they have to be added in very minute quantity only. Okay. Now coming to question number 76. Next question. Conveyor belt is manufactured from. See, if you depend only upon your textbook, your answer is neoprene. But if you make additional references, you will find styrene butadiene rubber, which is otherwise called BUNAS, can be used. Polyvinyl cloth is also used. So here also there is a confusion. There can be more than one possibility. But as per our textbook, neoprene alone is the answer. But many questions coming in KEAM get the answer from outside sources only. So even this is a questionable thing. Neoprene is not the only option for conveyor belt. Even BUNAS is used, PVC is used. So if you depend only upon the textbook, the answer is neoprene alone. Okay. The next question. Which one of the following is non-narcotic analgesics? Non-narcotic analgesic means non-habit forming. Non-habit forming. We know that morphine, codeine, heroin, which are given as other options, are habit forming. So our answer is paracetamol alone is the non-narcotic type analgesic. Bithionol is the another option which is added to soap as a antibacterial thing. Okay. Now question number 78. The primary precursors of photochemical smoke that can be metabolized by plants such as juniperus and pyracees. If you remember in environmental chemistry chapter, the primary precursors of photochemical smoke are nitrogen dioxide gas. The mentioned gases are nitrogen dioxide gas and hydrocarbons. And the secondary precursors are ozone and pan. Okay. So here our answer will be among the given nitrogen dioxide. So question number 78 get the answer A, nitrogen dioxide. Okay. Again, the next question, 79th question. Which among the following has maximum number of oxygen atoms? Highest number of oxygen atoms. Which one of the following has highest number of oxygen atoms? That question comes as the 79th question in the version D. 1 mole ferrous sulfate, 1 mole ferric sulfate, 2 mole ferrous sulfate, 3 mole hydrogen peroxide, 2 mole KMnO4, 1 mole K2Cr2SO. If you take 1 mole ferric sulfate, 4 into 3, 12 mole oxygen atom it will have. If you take 2 mole ferrous sulfate, 2 into 4, 8 mole oxygen it will have. If you take 3 mole hydrogen peroxide, 3 into 2, 6 mole oxygen will be there. If you take 2 mole KMnO4, 2 into 4, 8 mole oxygen will be there. If you take 1 mole potassium dichromate, it will have 1 into 7, 7 mole oxygen atoms there. Evidently, the answer is the first one with a 12 mole oxygen atom. A is the answer. Next question. Among the following pairs, the one that does not illustrate the law of multiple proportion. As we know, multiple proportion is applied to cases where two elements combine to form two or more different compounds. Only two elements and two compounds. If you go through the options, only in one case this is not correct. NO, NO2, it is valid. CuO, Cu2O, it is valid. FeO, Fe2O3, it is valid. H2O, H2S, it is not valid because there are three elements. So it cannot be applied. And lastly, NO, N2O, it is again valid. So here the answer is D, H2O and H2S. Next question, 87th question. It is actually, 81st question. After 81st question. A dinegative ion of element X consists of 10 electrons. A dinegative means X2 minus has 10 electrons. And also mention 8 neutrons. Since dinegative ion has 10 electron, its actual number of electron of the atom is 8 electron. So its number of proton is 8. Now we have the complete picture. X2 minus have 10 electron, 8 proton, 8 neutron, and the number of electron of X itself will be 8, isn't it? Okay. Now we have the second species Y2 plus. Y2 plus is said to have 12 proton. Okay, 12 proton. If you are interested in number of electrons in Y2 plus, it will be 10 electron because it has lost 2 electron. It itself will have, original atom will have 12 electron, but that is not our requirement. 12 proton, as of now 10 electron, and another statement given is that its number of neutron is 1.5 times the number of electrons of X. Number of electrons in X, not X2 minus, is, we have already found 8 electron. Okay. So 1.5 times that is the number of neutrons in the Y. So 1.5 into 8, 12 neutron. Now we know the number of proton, neutron and electron in both these cases. Now the question is, what is the ratio of mass numbers of X and Y? We know mass number is the sum of proton number and neutron number. In the first case, it is 8 proton, 8 neutron. So 8 plus 8, 16. Sum of sum of proton number and the neutron number. In the second case, we have already seen it is 12 proton and 12 neutron. So it's a mass number 12 plus 12. So in first case it is 8 plus 8. In the second case it is 12 plus 12. Means 16 is to 24, which is 2 is to 3. So for that question 81, the answer is B, which is 2 is to 3. Okay. The question number 82, it is like this. A particle of mass 6.6 into 10 to the power of minus 31 kilogram is moving with a velocity of 1 into 10 to the power of 7 meter per second. The de Broglie wavelength in angstrom associated with this particle is. Okay. We have to straightly apply the equation lambda is equal to h by mv. So here h is 6.6 into 10 to the power of minus 34. Mass of the particle is given 6.6 into 10 to the power of minus 31. And velocity is given to be 1 into 10 to the power of minus 7. That will give you the answer in meter, but we want the answer in angstrom. We know 1 meter is 10 to the power of 10 angstrom. So we have to multiply with another 10 to the power of 10, which gives you 1 angstrom. After cancellation, 1 will remain. So answer is the first answer A. Okay. The next question, 83. You have to identify terpineol and two ingredients of chloroxylenol and terpineol. We are familiar from the textbook itself, the structures of chloroxylenol and terpineol. Chloroxylenol is this. The name comes this way. If there is only 2 CS3 group, it is xylene, but it is having a chlorine group and it is a phenol also now, since OH is also present. So the name together becomes, it is not the scientific name, it's a common name, chloroxylenol, suggesting there is chlorine, there is xylene, means there are 2 CS3 group as well as a phenolic group. That's why it is chloroxylenol. You can remember it that way. And the terpineol is this thing, this structure. It's an alcohol, it's a phenol. It's an alcohol, it's a phenol. So A and C are these two structures. So that combination is given by D in the question paper. So for question number 83, dog is the answer. And question number 84. A fast-moving particle of mass 6.63 into 10 to the power of minus 28 gram can be located with an accuracy of an angstrom. The uncertainty in its velocity, Planck's constant, is given. See, so we want uncertainty in velocity delta V. Delta V is, we know, h by 4 pi on the other side, and you have to take m into delta x also to the other side. So delta V is 1 by m into delta x, h by 4 pi. See, mass is given 6.63 into 10 to the power of minus 28 is given in the question paper. We convert that to 10 to the power minus 31 to make it kilogram. So 6.63 into 10 to the power minus 31. And 1 angstrom, uncertainty in position is 10 to the power minus 10 angstrom. So in the denominator, in the place of 1 by m delta x, we have 1 by 6.63 into 10 to the power minus 31 into 10 to the power minus 10. And x by 4 pi, if you make it a by heart value, it is 5.3 into 10 to the power minus 35. Okay, 5.3 into 10 to the power minus 35. After simplification, you get a value 8 into 10 to the power 5. 8 into 10 to the power 5 will be your answer. So C is the answer for that question. Okay. Now question number 85. Which one of the following molecule contains an incomplete octet at the central atom? See, SF6. We know sulfur is having 12 electrons in its valence shell. So that is not the case. AlCl3. Aluminium is having 3 bonds and 1 vacant orbital. So it is having only 6 valence electrons. So its aluminium's octet is not complete. So that could be the answer. CH4, 4 bonds, 8 electron. PF5, 5 bonds, 10 electron. H2O, 2 bonds and 2 lone pairs of electrons around central oxygen atom. So again 8 electrons. So incomplete octet, this one, B is the answer. Okay. Now coming to 86th question. Which one of the reaction involves a change from sp2 to sp3 hybridization? Let's check. CH4 when becomes CH2Cl2, hybridization of the central carbon continues to be sp3. So that's not the answer. NH3 becoming NH4 plus, ammonia becoming ammonium ion. We know both are having central carbon atom. Central nitrogen atom sp3 hybridized. AlCl3, AlCl4 minus. Yeah, here sp2 changes to sp3. Trigonal planar sp2 hybridized aluminum chloride changes to a perfect tetrahedral shaped AlCl4 minus. So there the hybridization changes from sp2 to sp3. H2O, H3O plus. Here no change in hybridization. sp3, sp3. Only changes the bent shape changes to pyramidal shape. That's the change. Okay. And the last one, PCl3, PCl5. PCl3, like NH3, NCl3, etc., is having sp3 hybridization with a pyramidal shape. Whereas PCl5, we know the hybridization is sp3d and we have trigonal bipyramidal shape. So there also sp3 changes to sp3d. So the answer is AlCl3 changing to AlCl4 minus. That is where sp2 hybridization changes to sp3. Okay. Answer C there. And question number 87. The dipole-dipole interaction energy between rotating polar molecule is proportional to where r is the distance between the centers of the polar molecule. C, if it is induced dipole interaction, interaction, we know interaction energy E is proportional to, question number 87. The dipole-dipole interaction energy between rotating polar molecule is proportional to dash, where r is the distance between polar molecules. If you remember, if the molecules are induced dipole type, not having permanent dipole, in that case the interaction energy is the weakest, where E is proportional to 1 by r to the power 6. Okay. If the molecules are polar, the interaction energy is stronger, where interaction energy E proportional to 1 by r to the power 3. But there is a restriction. Only when the molecules are static, non-moving, this happens. When the molecules are moving, rotating, etc., the interaction energy becomes weak, as in the case of induced dipole, and goes back to the same value 1 by r to the power 6, not 1 by r to the power 3, because in this question they have specifically mentioned when the rotating polar molecule, if the molecules are rotating. So it is as weak as induced dipole. So answer is E, 1 by r to the power 6. Okay. Question number 88. A metal X crystallizes in a body-centered cubic structure and its metallic radius is 346.4 picometer. The length in picometer of the unit cell is the edge length. Length means they really mean edge length. So please remember the relation between edge length and radius for a body-centered package. We know it is root 3a is equal to 4r. We want to get A. A is equal to 4 by root 3r. 4 into R is given 346.4 picometer and root 3 is 1.732. Substitution gives you 800 picometer. Okay. So answer is B there, bold there. Next is question number 89. It is from thermodynamics. The standard enthalpy of formation of CH4 gas, CO2 gas and H2O liquid are minus 75 kilojoule per mole, minus 393 kilojoule per mole and minus 286 kilojoule per mole respectively. The amount of heat liberated in kilojoule when 3.2 gram methane gas is burned under standard conditions is. Here, the first thing we have to do is to write the balanced chemical equation for the combustion of methane. We have written that. Okay. Then we know that for any reaction, the enthalpy, standard enthalpy change of the reaction, here that this reaction is enthalpy of combustion also. Okay. So, delta reaction standard enthalpy change of the reaction in standard condition is the enthalpy of standard enthalpy of combustion, C. Okay. What is that? Total enthalpy content of the product minus total enthalpy content of the reactant. That will be the enthalpy change during the reaction. Total enthalpy content of the product minus total enthalpy content of the reactant. But enthalpy content of each compound is the enthalpy of its formation. So, instead of using enthalpy content, we can use their respective enthalpy of formation. So, here what we have to do is to add up the enthalpy of formation of the products and then subtract from it the total enthalpy of formation of the reactants. This data is given in the question. So, what is the enthalpy of formation of product as a whole? 393 for carbon dioxide, minus 393. There are 2 water moles, so 2 into minus 286 for water. That is the total enthalpy of formation of the product minus enthalpy of formation of the reactant. Methane, it is given minus 75. Being a standard element, its enthalpy of formation is 0. So you get 890 kilojoule per mole. But here it is per mole. And we want to know what is the heat release when a particular mass 3.2 gram of methane is burned. So how to proceed? Therefore, enthalpy of combustion standard for 3.2 gram of methane. We know for 16 gram, that is for 1 mole it is 890. In that case for 3.2 gram, it is 178 kilojoule. E is the given answer here. Okay. Next question, question number 90. Which one of the following is the correct relationship between Cp and Cv for 1 mole of an ideal gas? See, for all gases when they are ideal, Cp minus Cv is equal to R. If it is monoatomic, Cp is 5 by 2R, Cp is 3 by 2R. So 5 by 2 minus 3 by 2R is equal to R. If it is diatomic, 7 by 2R minus 5 by 2R, again R. If it is polyatomic, 4R minus 3R is equal to R. So that is common for all these gases provided they are ideal. So since Cp minus Cv is equal to R, Cp is equal to Cv plus R. Anybody knows that. So the answer is B there. Cp is equal to Cv plus R is the correct answer. And the next question 91. They have given you a set of chemical equilibria and the corresponding equilibrium constant value. And you are asked some of the reactions and equilibrium constant Kc are given. Choose the reaction which proceeds rarely at that given temperature. They have given certain reactions and their Kc values at the experimental temperatures. Some experimental temperatures are same, some are different. But they are asking you at that given temperature which is proceeding the least. See, when the reaction proceeds the least, product concentrations will be the lowest. So, in the equation for equilibrium constant Kc, product concentration comes in the numerator and reactant concentration comes in the denominator. If reaction proceeds only very little, Kc value will be very low, isn't it? So, here out of the given Kc values, I haven't written all the values here. One value is extremely small and there is only one value with a negative power for 10, which is this. N2 gas plus O2 gas is 2NO gas, 4.8 into 10 to the power of minus 31. So, doubtless anybody can select that as the answer because it is having a very low product concentration. That's why it is having a very low Kc value. So, in this question, our answer is this one with the D option. Okay? Yes. We proceed to the next. The next question, question number 92 from chemical equilibrium. This is one of the standard question in this question paper. There are only few difficult problems in this question paper. Most of the other ones are simple average or even below average. Few questions are having good standard. This is such a one. The equilibrium constant for the following two reactions at 298 Kelvin are given below. Two equations are given. These two equations. What is the K value for the reaction A plus of B given? Okay. Two equations are given. Their equilibrium constant is given. Then you are asked to find the equilibrium constant for another reaction. This is the required equation whose K value has to be determined. And for getting that, we are provided with the two other equations. 2A reversibly giving B plus C, K1 is equal to this much. Second one, 2B plus C, 2X, K2 is equal to this much. See, now you have to plan how to get this equation from these two. For that, here what I have done is, first we will add them. See, look here. So first you write all the reactants together. 2A plus 2B plus C. Reversible arrow. Now write all the products. B plus C plus 2X. Okay. There are some simplification that comes on. B, there is 2B here, 1B here. So 1B cancels. C on both sides. So C cancels. So what remains is 2A plus B reversible arrow 2X. Since we have added the two equations, to get the K value for the new reaction, we have to multiply the K values. So this equation is 3. K3 is equal to K1 into K2. K1 is 16, K2 is equal to 25. So 400. Now we verify how to get this equation from this equation. See, if this equation is multiplied throughout with 1 by 2, you get the required equation. So fourth equation, half into 3. Third equation is this. You multiply it with 1 by 2. So you get A plus 1 by 2B reversible arrow X. So what is the new equilibrium constant K4? When you multiply a given equilibrium equation with a common coefficient, the new K value will be the K value of the earlier one with the power, with this coefficient as its power. Since you have multiplied with the 1 by 2 here, that 1 by 2 become the power of the earlier K value. So K4 will be K3 to the power 1 by 2. That is 400 to the power 1 by 2. When you multiply the equilibrium equation with a common coefficient, to get the new K value, you make this coefficient as the power of the earlier K value. So 400 to the power 1 by 2, 20 is the answer. E is the answer for question number 92. That's a good question. You have to spend some time how to get this equation from these two. Okay. So that's it. Now question number 93. The average oxidation state of bromine Br308. Br308. You want to know the average oxidation state of each bromine atom. So what is the total oxidation state of 8 oxygen atom? 8 into minus 2, minus 16, isn't it? So total oxidation of bromine will be plus 16. Since all the 16 electrons are provided by bromine, total oxidation state of bromine is plus 16. So divide it with the 3 to get the average oxidation state of each bromine. Average oxidation state of bromine, 8 into 2, 16 by 3 is equal to 16 by 3. A is the given answer for this particular question. Next question. It is another good standard question. It can be said to be from redox reaction, or you can even say it is from electrochemistry. Both are correct. Okay. See, they have given a set of SRP value for different half cells. If you want to get the answer, you have to arrange them either in the decreasing order or increasing order. Either you have to write it or you have to keep those information in your mind. For simplicity of understanding, I have rewritten those values in the decreasing order. See, here all reactions are reduction. Br to become Br minus is reduction. Ag plus becoming Ag is reduction. Fe3 plus becoming Fe2 plus is reduction. I2 becoming I minus is reduction. Cu2 plus becoming Cu is reduction. Fe2 plus becoming Fe is reduction. Zn2 plus becoming Zn is reduction. So these values are SRP values. And how they are arranged in the decreasing order. 1.09, 0.8, 0.77, 0.54, 0.34, minus 0.44, minus 0.76. So SRP values are arranged not in the question, it is not in the regular order, but we have to rewrite them, rearrange them. And one more thing you have to remember, when you couple any two cells, half cells from this to get a full cell, that with higher SRP, high standard reduction potential, will have high reduction tendency, not reducing tendency, self-reduction tendency, and so will act as cathode. So the lower one will be the anode. That half cell with the higher SRP will be cathode, lower SRP will be anode. So one above will be cathode, one below will be anode in any coupling. Okay? In any combination, above one cathode, below one anode. Now we want to know which is improper here. See, predict the reaction that is not feasible here. First question, it is a reaction between Fe3 plus and I minus. How to verify Fe3 plus and I minus? Look, Fe3 plus I minus. You are going to couple these two. So you know that this will undergo reduction, this will undergo oxidation. This is cathode, this is anode. So we write what really happens here. Fe3 plus become Fe2 plus. Fe3 plus become Fe2 plus. I minus become I2 because it is oxidation. So this will come as the reactant. I minus becoming I2. First actually this balancing I done later. So Fe3 plus plus I minus giving Fe2 plus plus I2 will be the reaction that will happen. Now I balanced it by putting 2 I minus here, 2 Fe3 plus 2 here. So now it is balanced. So this will be the actual reaction happening in the first case. Now second combination, Ag plus NCu. We will check for the answer later. Ag plus NCu. Ag plus NCu. It is a difficult one. Takes some time. Ag plus NCu. Yeah. This acts as cathode. This acts as anode. So Ag plus become Ag at the cost of Cu becoming Cu2 plus. So Ag plus and Cu will be the reactants. Ag plus plus Cu giving Ag plus Cu2 plus. Then I balanced 2 Ag plus plus Cu giving 2 Ag plus Cu2 plus. That's regarding the second one. The third combination, Ag and Fe3 plus. Ag and Fe3 plus. Ag we get from here, Fe3 plus we get from here. So this will undergo reduction, this will undergo oxidation. So Ag plus and Fe2 plus will be the reactant. Ag plus plus Fe2 plus, it gets reduced to Ag, this gets oxidized to Fe3 plus. So that's regarding C. Now D, Br2 and Fe2 plus. Br2 and Fe2 plus. Br2 and Fe2 plus. But Fe2 plus comes in two cases. Fe2 plus, Fe2 plus. So we are bothered which has to be taken. So please read it again. Br2 oxidizes Fe2 plus. Fe2 plus if oxidized become Fe3 plus. So we must connect that involving Fe3 plus because we discuss whether it can be oxidized or not. So take this case, Fe3 plus and Br. So this will be acting as cathode, this will be anode. So Br2 and Fe2 plus will be the reactants. Br2 plus Fe2 plus giving Br minus and Fe3 plus. Now balance. Br2 plus 2 Fe2 plus. In balancing you can do Br minus plus 2 Fe3 plus. Okay, and the last one. Zinc and copper ion. So you have to connect zinc and copper, these two. So this will be cathode, this will be anode. Cu2 plus reactant, Zn reactant. Cu2 plus plus Zn giving Cu plus Zn2 plus. Now we are ready to check which answer is correct. First one says Fe3 plus oxidizes I minus. Please check. Fe3 plus oxidizes I minus. Correct. Fe3 plus became Fe2 plus undergone reduction. I minus oxidized to I2. So A is correct. Now second one. Ag plus oxidizes Cu. Ag plus oxidizes Cu. Cu has become Cu2 plus. Ag plus has reduced to Ag. So that is also correct. C. Ag reduces Fe3 plus. Ag reduces Fe3 plus. Not on this side. Look at the product side. Ag reduces Fe3 plus. If that happened, the product would have been Ag plus plus Fe2 plus. But that is the reverse reaction that is spontaneous. So the mentioned statement is incorrect. That will not happen because the reverse is the spontaneous reaction. So this must be our answer. So this is wrong. This is correct. This equation is correct. So this is wrong because the given statement is the reverse reaction. That is wrong. This will happen. This will not happen. So C must be our answer. The statement C corresponding to the reverse reaction. So that is wrong. D. Bromine oxidizes Fe2+. Bromine oxidizes Fe2+. Fe2+ become Fe3+. So it has oxidized. Bromine becoming Br- get reduced. So that's also correct. E. We have to verify all. Suppose in a question more than one answer is correct, we have to check all. So never stop when one answer is, in this particular it is not like that. Still we have to verify all. It's a learning process also. Zn reduces Cu2+. Zn reduces Cu2+. So Zn becomes Zn2+, Cu2+ becomes Cu. So we conclude this is also possible. So we conclude that C is wrong because the mentioned chemical change is non-spontaneous. The reverse is spontaneous. So our answer is C. So this I will say one of the most difficult question in this question paper. Okay. Next question. Question number 95. The chemistry teacher asked the students to prepare 20% weight by weight solution of urea in water. Which one of the following solution does not conform to the required composition? Mass ratio is 1:4. 20% is to 80%, isn't it? So, in which case the mass ratio does not correspond to that will be our answer. Here look, for the first four options, 6:24, 1:4, 20:80, 1:4, 10:40, 1:4, 4:16, 1:4. The last composition, 16:30, 1:2. So simple a question. So, answer is E. The next question. Question number 96. The vapor pressure of pure liquids X and Y 350 at the 350 Kelvin 200 millimeter and the 300 millimeter of mercury respectively. Then the correct vapor pressure in millimeter of mercury of an ideal solution containing X and Y in the molar ratio 3:2 at the same temperature. Very simple question. Straight application. P total we know partial pressure of A plus partial pressure of X plus partial pressure of Y. But partial pressure of any component is total pressure, vapor pressure of the pure component into its mole fraction. So P total is equal to vapor pressure of pure A, pure X into mole fraction of X plus vapor pressure of pure Y in the mole fraction of Y. Vapor pressure of pure X is given as 200 and the ratio is 2:3, 3:2. So mole fraction will be 3 divided by 3 plus 2. So 3/5 plus vapor pressure of pure Y given in the question 300. And it's a mole fraction 2 divided by 3 plus 5. 2 divided by 3 plus 2. 2/5. So upon computing you get a 240 millimeter mercury. It's an easy one. Okay. So answer is D there. Question number 96 D. Now question number 97. This have a wrong option given as answer in the key provided by the authority. You must question it. See why. The question is, in a reaction 3A giving products, the concentration of decreases from 0.4 mole per liter to 0.1 mole per liter in 20 minutes at 300 Kelvin. The rate of decrease in concentration of A during this interval in mole per liter per minute at the same temperature. See, minus dA by dt is minus final, what is change in concentration? Final concentration minus initial concentration. 0.1 minus 0.4 divided by dt time interval 20 minutes. So it will become positive. The value will become positive. Upon computing you get 0.015 mole per liter per minute. That is supposed to be the change in concentration of A. But they have given 0.005. That is 1/3 of this as the rate change. It is a wrong answer. The answer is not A. Its answer is B. Why? That is overall rate. Whenever we find overall rate, we have to multiply the rate in change of concentration of A with the inverse of its coefficient in the balanced chemical equation. Overall, whenever you want to get the overall rate, it will be dx by dt 1/3 minus dA by dt. Then only you get 0.005 mole per liter per second as the answer. So 0.005 is an answer, but it is not the rate of disappearance of A, but the overall rate of the reaction. There only you have to multiply with the 1/3. So this answer multiplied with 1 by 3 is a wrong answer, which sadly is given as the correct answer. You must question this, otherwise even if you answered correctly, you will go wrong. And instead of getting +4, you will get -1. So please take care, you report it. Okay, you claim the mark. Okay. Okay. Just a minute. Next question, the 98th question. The critical temperature, the 98th question. The next one. It is from kinetics. The half-life period of a first-order reaction at a 298 Kelvin is 20 minutes. The time in minute required for 99.9% completion of the reaction at the same temperature. See, you can derive. I am not going into the details. You can conclude to a point like this. T90% is 3.3 T half. T99% is 6.6 T half, and T99.9% is 9.9 T half. Please remember 90, 99, 99.9, 3.3, 6.6, 9.9 T half. This 9.9 T half can be approximated to 10 T half, isn't it? So our answer T99.9 is equal to 10 into T half, 10 into 20, 200 minutes. So our answer is 200 minutes. Option B is our answer. So please make this by heart. 99, question number 99. The critical temperature of some gases are methane. Some gases critical temperature is given. And the question is the gas that is adsorbed to the maximum extent on 1 gram of activated charcoal at a given temperature. See, you have to remember, higher the critical temperature, easier to liquefy it. When the critical temperature is high, it will be very easy to liquefy it. For example, ammonia has a high critical temperature, whereas hydrogen has a very low critical temperature. So ammonia is very easy to liquefy. Very easily liquefiable gases are very easily physisorbed also. So you can say that higher the critical temperature, higher the extent of physisorption. So in the given list, it is not ammonia but N-butane that is having the highest critical temperature. So we can say that maximum physisorbed gas is not ammonia but N-butane, and that is the given answer also. Question number 99. D is the answer, N-butane. And 100th question, which is the wrong regarding physisorption. See, it arises because of van der Waals forces. Correct. Physisorption is resulted from weak van der Waals forces. It is not specific in nature. Correct. Physisorption can happen on any gas. Okay, all gases are physisorbed to lower or higher extents. High activation energy required? No, not at all. It can happen even at a very low temperature. Physisorption can happen at all temperatures. It is not. I repeat the question number 100. Which one of the following is not true with regard to physisorption? Which is wrong regard to physisorption? First option, it arises because of van der Waals forces. We know physisorption results from weak physical forces like van der Waals forces. B, it is not specific in nature. Yeah, correct. Because metals can absorb different type of gases. Different gases to greater or lesser extent, charcoal, etc. So it is not specific in nature. It can absorb any gas. High activation energy is needed. That's not true. It can happen at all temperatures. Even at low temperature, physisorption can happen. So only the activation energy is required for chemisorption, where some sort of new chemical bonds are formed. So activation energy is required there only. High activation energy is required in chemisorption only. So high activation energy requirement is not a requirement of physisorption. So that is wrong. C is wrong. It depends on the nature of the gas. Yeah, different gases, as we have seen already, easily liquefiable gases are easily physisorbed. So you can say that it depends upon the nature of the gas. Enthalpy of adsorption is low, 20 to 40 kilojoule per year. Enthalpy of physisorption, the heat released during the physisorption process is low compared to chemisorption, which comes in the range 80 to 240 kilojoule. Here it is only 20 to 40. Okay. So answer is C here. Now, okay. Now we proceed to the next question. The next question, 101. It is a cross combination type question. Okay. We have a set of hydrides. We have to match the appropriate hydride. Look here. I have given the answer here. Saline hydride. Among the given options, saline hydrates are ionic hydrates mostly formed by alkali metals and alkaline earth metals. Okay. Saline hydrates. Among them, the only given metallic saline hydrate, not metallic hydrate, saline hydrate is beryllium hydrate, even though it is having some polymeric character with some covalent character. In the given list, it is the only saline hydride. So, beryllium hydride. Then, electron deficient hydride. It is diborane B2H6. We know that this compound is having 3-center 2-electron bond. Diborane, we have studied that in the first year. P block elements. Diborane B2H6. It is having 3-center 2-electron bond. That means there is deficiency of electron. So, electron deficient, we have to match with the diborane B2H6. Then electron precise, methane. In methane, the central carbon is having 4 bonds around it and 8 electron, neither less nor more. Exactly what is required. So, 8 electron, all these 8 electrons are involved in bonding also. Such compounds are called electron precise compounds, CH4, CCl4, SiCl4, etc. Okay, then electron rich. Electron rich doesn't mean more than 8 electron, but it means it is having 8 electron, but among them some are lone pairs that can be donated to someone else. Okay, so some other species cells. In H2O we know that there are 2 bond pair and 2 lone pairs. So H2O, NH3, HF. All these are electron rich hydrides because in NH3 there is 1 lone pair, in H2O there are 2 lone pair, HF there are 3 lone pairs. So we can consider all these 3 as electron rich hydrides. Then we have metallic hydride. Metallic hydrides are mostly formed by transition metals where it is as if the hydrogen atoms are occupying the lattice of metal, even though it is not exactly so. Still, that's the general nature of metallic hydrides. Chromium hydride is given as an option. So, that is the answer. So, that is the matching and this matching comes for D. Option D is the answer for that question. Okay. Now, we go to the question number 102. The metal which dissolves in liquid ammonia to give a blue-black solution due to formation of solvated electron. We have studied that in alkali metals, S block elements. We know alkali metals and alkaline earth metal both dissolves in ammonia to form ammoniated electron giving deep blue solution. Here among the given metals, only calcium belongs to S block. So calcium is the answer. Question number 103. Which one of the following process does not produce dinitrogen? In which case there is no evolution of nitrogen. That's the question. They are given a set of information. First one. Thermal decomposition of ammonium dichromate. Thermal decomposition of ammonium dichromate. If you remember, NH4, you have studied this in P block second year. NH4 twice Er2O7 upon heating decomposes to produce nitrogen gas, chromium trioxide and water. This chemical reaction is called a chemical volcano. If you strongly heat a heap of powdered ammonium dichromate, it will puff out. Due to the evolution of nitrogen gas and a green powder of chromium oxide will be sent around like the eruption that happens. Okay, so it is called a chemical volcano. Where nitrogen is one of the product. Okay, then heating barium azide. Azide means N3 minus ion. So Ba N3 twice upon heating produce metal barium and nitrogen gas. Then mixing ammonium chloride and sodium nitrate solutions. Ammonium chloride plus sodium nitrate, if double decompose, means if the ions are exchanged, we have ammonium nitrite and sodium chloride, isn't it? This ammonium nitrite upon thermal decomposition evolve nitrogen. So if you mix ammonium chloride with the sodium nitrite, there is a possible combination of formation of ammonium nitrite, which thermally decompose, and the final products are N2, H2O and NaCl. So there also nitrogen is one of the decomposition chemical reaction products. Then thermal decomposition of sodium azide. Thermal decomposition of azides are one of the best method to prepare pure nitrogen, if you remember. Na-N3 thermal decomposition, Na plus 3N2. So there also you get nitrogen. Lastly, ammonium nitrate thermal decomposition. Ammonium nitrite upon thermal decomposition gives you nitrogen. But ammonium nitrate, one oxygen is excess, no? That oxygen remains with that nitrogen molecule. So instead of N2, you have N2O upon thermal decomposition. You get laughing gas or nitrous oxide or nitrogen monoxide. So this compound will not be given for salt analysis because if you start laughing, because it is not that much serious. It produces N2O. Small amount it will not cause any effect, but in huge amount it may give a relaxed feeling that may lead to breaking out of a laugh. Okay. Okay, we go to the next question. The next question, 104. Which of the following compounds is used as a refrigerant? The very first option is CCl2F2. The other gases are, we know from, by familiarity, are not the refrigerant gases. CCl2F2 is Freon 1,2, which is a very popular refrigerant. Okay, so answer is A. Question number 105. Which of the following set of transition metals have high volatility? If you remember, the last D block metals set zinc, cadmium and mercury with the NS2 N-1D10 configuration. Zinc, cadmium and mercury. What's the specialty? These atoms, the atoms of these metals have completely filled d subshell, so they are not free for binding up the atoms together in a crystal. So what happens? Only 2 electrons are set free by each atom for binding atoms together. Valence electrons set free are only 2 per atom. So their binding is comparatively weak when you compare them with other d block elements. So due to this weak binding forces, they have low melting point and high volatility. Okay. So your answer E, zinc, cadmium and mercury. Okay. Well, next question is, this question is actually present in our textbook itself. It is from D block metals. Listen here. Both chromium and Cr2 plus and Mn3 plus have D4 configuration. Then which one is true? The options are both are reducing agent, both are oxidizing agent, like that. To understand that, we will look into the clear picture of this. See, chromium valence electronic configuration 4s1 3d5. We know it is the case where electron jumps from s orbital to inner d orbital. 4s to 3d2 given exactly half-filled electronic state. So what will be the electronic configuration of Cr2 plus? We know that during ionization, one or both ns electron have to be removed before removing any n-1d electron. So when you are removing 2 electrons, this s electron will be lost and one of the d electron also will be lost. So presently Cr2 plus have 4 unpaired d electrons. Okay. Now take the case of manganese. Manganese is the next element after chromium. So it is having one more electron than chromium. That pairs here. So it get 4s2 3d5. Now think about Mn3 plus. As I told you, both the s electron will be lost first, one d electron will be further lost. So this will be also having 4 d electron like chromium. So will they both act as oxidizing agent or reducing agent? One as oxidizing and the other as reducing. Their present electronic condition is the same. What happens is that chromium, listen carefully, releases one more electron and become D3 configuration. Why? We know D3, D subshell can be split into two in an external field, T2G and EG. Now, EG 2 orbital, T2G 3 orbital. These three orbitals have a different energy than the other orbital. T2G orbitals are called non-axial orbital and EG orbitals are axial orbitals, which are T2G orbital, dxy, dyz and dxz. These are T2G orbital, non-axial orbital, and the EG orbitals are Tx square minus y square and Tz square. Chromium releases one more electron that it can have an exactly half-filled T2G shell. T2G. Not all the d orbital together, the T2G is exactly half-filled. So, chromium prefers to release the electrons. So, since it is getting itself oxidized, chromium ion acts as a Cr2 plus acts as a reducing agent. What about manganese? Manganese instead accepts an electron from other species, prefer to accept an electron from other species. Then what it becomes? D5. D4 is present, it becomes D5 by accepting an electron so that it is having an exactly half-filled D shell as a whole. Here part of D shell, that is T2G, a part of D subshell, the other part is EG. In this case, it prefers an half-filled T2G. In the case of manganese, it prefers an half-filled D subshell as a whole. So, by releasing one electron, Cr2 plus acts as a reducing agent. By taking away one electron from other species, manganese acts as an oxidizing agent. So, this is well explained in our textbook itself as a column question, as a box question, where it is clearly mentioned. Why it is not happening the other way? Why this is not accepting electron and this is releasing electron? It is not answered, but this thing is very well explained why it happens so. Okay, we are supposed to know that much only. Okay, so our answer B here, Mn3 plus is an oxidizing agent because it itself gets reduced, and the Cr2 plus is a reducing agent because it itself gets oxidized. So up to 106. Okay. The elemental analysis of an organic compound gave C 38.71%, H 9.67%. What is the empirical formula of the compound? So here we have to first find the relative number of moles from the given mass persons. Relative number of moles of atoms. Relative number of moles of atoms of carbon, hydrogen and oxygen. Divide the mass percent of carbon by its atomic mass 12. Divide the mass percent of hydrogen by its atomic mass 1. Add up these two percents to get a total value. Subtract it from 100 to get the percentage mass of oxygen. Then you get 51.62. Divide that mass percent by atomic mass of carbon 16. Then you get 3.2, 9.67, 3.2. So ratio of moles of atom. Take the ratio of this 3. 3.2 is to 9.67 is to 3.2. To get the simplified ratio, you divide this ratio with the smallest of the three values, which is 3.2. So 3.2 divided by 3.2, 9.67 by 3.2, 3.2 divided by 3.2. 1 is to 3 is to 1. So the empirical formula will be CH3O. Hope you understood that. Now question number 112. Which one of the following molecule contain only primary and tertiary carbon? First one, 2,2-dimethyl butane. 2,2-dimethyl butane. Correct. Then second one, 3-methyl pentane. Pentane, 3-methyl pentane. Correct. Third one, C, 2,3-dimethyl butane. Butane, 2,3-dimethyl butane. Correct. N-hexane, 6 carbon in a row. And lastly, 2-methyl hexane. 2-methyl hexane. Now we will check for primary, secondary, tertiary. In the first case, primary, 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 primary. This is secondary, this is quaternary. So this is having primary, secondary and quaternary, but not tertiary. Second one, primary, secondary, tertiary, secondary, primary. This is also primary. It is having primary, secondary, tertiary, but not quaternary. Here, 2,3-dimethyl butane, Primary, 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 tertiary, tertiary. Yeah. This must be our answer because it is having only primary and tertiary, no secondary, no quaternary. That one, two terminal ones are primary, all the non-terminal ones are secondary. So it is having primary and secondary, not tertiary, no quaternary. Here, primary is there, tertiary is there, secondary, 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 primary, this is also primary. So it is also having primary, secondary and tertiary. So our answer is C, which is having primary and tertiary only. 2,3-dimethyl butane is our answer. Okay. Next one, question number 113 with 113. Calculate the number of sigma and pi bonds in 2n-propyl pent-1ene. 2n-propyl pent-1ene. Here, the longest chain is pent only, not this one, because that does not include the double bond. So it can be named only that way. 1-propanyl pent-1ene. Okay. Okay. Now to get the not to miss the bonds, you draw such a diagram where all the bonds are separately shown. Then you won't miss any bond. See, now we can count the bonds. Sigma bond, only one pi bond is there, that's sure. Then sigma bond. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 1 and 23 bonds are the answer. So our answer will be B, 23 sigma bond and 1 pi bond. Okay. Next question, 114. Which of the following molecule give 4 isomeric monochlorides on photochemical chlorination? 4 different monochloride derivatives will be given by which alkane? See, what are the options? 2-methyl propane. This is propane, so 2-methyl propane. Correct structure. Then N-butane. N-butane, correct structure. Then 2-methyl butane. 2-methyl butane, correct structure. Then 2,3-dimethyl butane. 2,3-dimethyl butane, correct structure. And propane. Okay. Now we have to verify in each compound how many different variety of carbon atoms are there, also having hydrogen on them. That much different monochloro derivatives you can prepare. For instance, consider here. This compound, look, this carbon, this carbon, this carbon are identical. Even though in the figure it may not appear like that, isn't it? These three are identical. If you draw this central CH and draw it like a bench shape, you will feel that they are identical. Even though in this presentation you may not feel like that. But actually they are identical. 1, 1, 1, 2. So there are two different type of carbon having substitutable hydrogen on them. So you can get only 2 monochloride derivative. You can substitute one hydrogen from here or here or here. You get one monochloride derivative. Then you can also substitute here. You get the second monochloride derivative. Only 2 possibilities are there. Now come over here. 1, 2, 2, 1. This and this are identical. This and this are identical. So you can have only 2 monochloride derivative, 1 chlorobutane and 2 chlorobutane only. No more. Okay. Now come over here. This methyl and this methyl are identical. If you draw like this, you will feel they are identical. Only because drawn like this, you may feel that they are different. No, they are identical. If you draw like this, they are identical. No, so they are actually identical. But that these two and this methyl, even though both the terminal are not identical, this is a different type. Why I say so? The carbon attached to this carbon, whereas this and this are attached to a tertiary carbon. This is a secondary carbon. So this is attached to a secondary carbon, whereas this and this are attached to a tertiary carbon. So they are different. So you have one identical carbon, second different carbon, third different carbon, 4 different varieties of carbons are there. All of them have substitutable hydrogen also. So here you can get 4 monochloride derivatives from 2-methyl butane. You can get 4 different types of monochloride derivatives. So this will be our answer. And here this carbon, this carbon, this carbon, this carbon are identical. Okay. So substituting with the chlorine gives only 1 derivative. This and this are identical. That gives a second variety. So there is 2 monochloride derivatives. Coming over here, E. This and this propane, this and this are identical. This is different. So you get 2 monopolar derivatives. So our answer is C. That gives 4 different monopolar derivatives. 2-methyl butane gives you 4 different monopolar derivatives. Question number 115. Which of the following aryl chlorides on warming with the water forms corresponding phenol? Simply warm with the water and you get a phenol. Chlorine nucleophilically substituted by an OH group. Nucleophilic substitution of chlorine is actually difficult. But when there are three electron withdrawing NO2 groups, especially present on 2 ortho and para position, we have highly activated nucleophilic substitution. If it is simply chlorobenzene, you have to apply temperature, pressure, NaOH, few concentrated NaOH, then only you can have this Cl substituted by OH. When there is one nitro group, you can lower the temperature to some extent. If there are 2 nitro group, you can still lower the temperature to even more low extent. If there are 3 nitro group, you simply have to warm with water so that this chlorine is very easily substituted by OH. So in this particular case, it is 2,4,6 tri-nitrochlorobenzene that is easily converted from chloro to phenolic group. Okay, so answer is C there. Question number, okay. Next, question number 116. Resorcinol is. Resorcinol, catechol, resorcinol and quinol we study together. It is benzene diols. See, benzene 1,2 diol is catechol. Benzene 1,3 diol is resorcinol. And benzene 1,4 diol is quinol. Catechol, resorcinol and quinol. So our answer is resorcinol. When resorcinol is benzene 1,3 diol. So our answer is A, which suggests 1,3 benzene 1,3. Now the last questions. 117. See, in 117 you have to arrange a set of phenolic compounds in the order of acidity, decreasing order of acidity. The compounds given are metanitrophenol, paranitrophenol, paracresol, phenol. These 4. See, when an electron withdrawing group is present on the ortho or para position of the acidic group, OH group is the acidic group here, it will have maximum tendency to ionize. So, paranitrophenol, among the given 4, paranitrophenol will be the strongest. Then, if an NO2 group comes on the meta position, even now, inductively, it can help the ionization of OH group by withdrawing electron inductively, but not through resonance. Why? Due to resonance, positive charge comes only on 2 ortho and para position, not on meta position. So, inductive strengthening is very little, comparatively little, but still it is better. It is more acidic than simple phenol, because as I told you, inductive effect is still there. Then lastly come paracresol, because paracresol means para position 1 methyl group is present. It is electron releasing group. Electron releasing group always disfavors ionization of phenol, so that comes the last. Such a combination is given in option A. So the answer for question number 17 is option A. Question number 118, which is valeraldehyde. Valeraldehyde is nothing but pentanol. It's a common name. So CH3, CH2, 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 CHO. Pentanol is valeraldehyde. Option A is the answer. Toluene on treatment with the chromic oxide in acetic anhydride at 273 to 283 Kelvin gives. See, this is a method to prepare benzaldehyde. We have in our textbook, it is the toluene plus acetic anhydride, chromium trioxide catalyst 273 to 283 Kelvin. It adds on to acetate group to give benzalidene diacetate. Benzalidene diacetate, its structure is this. So, its answer is benzalidene diacetate. In our textbook, one more step is given, which is hydrolysis, whereby benzalidene diacetate gives you benzaldehyde and 2-acetic acid molecule. But here the question not about ionization. Okay, so our answer benzalidene diacetate, B is the answer. Now last question, question number 120, last question. See, there are set of amines are given, and you are asked to say which is the strongest and which is the weakest. For this, I have given a full set of bases we come across, and from that list we can get the answer. See, dimethyl aniline is the strongest, then triethyl aniline, diethylamine, then triethylamine, dimethylamine, ethylamine, methylamine, trimethylamine, then benzylamine, ammonia, C6H5 N-dimethyl aniline, N-methyl aniline, and aniline. Try to make this somehow by heart. Then only you will be able to answer a question like this. Then we will see from the given list, this is the weakest. Aniline is the weakest. And in the list, the strongest is ethylamine. So our answer will be the combination suggesting aniline and ethylamine, which is option D. That's the answer. So with that, we come to a conclusion of the discussion of this question paper. All the best. I have given this expression not only for those who are going to get through the exam, but also for those who planning to prepare for repeaters. Okay, take care. Bye. Hi. In the video taken, we missed some questions in between during editing. We will discuss them here right now. From question I think 107, 108, 109 and 110. These are the questions we missed in the sequence. So we go through them. 107. The complexes CONH3 5 times NO2Cl2 and CONH3 5 times ONOCl2 are coordination isomerism, geometrical isomerism, solvate isomerism, ionization isomerism, linkage isomerism. See, here the isomerism arises due to the way in which the group NO2 is attached to the central nitrogen atom. Central cobalt atom. In one case, this NO2 group is attached through nitrogen atom. Okay. And in the other case, the same NO2 group is attached to the central cobalt through oxygen atom. Such ligands are called ambident ligand, not bidendate ligand, ambident ligand, either using this atom or using that atom. So they give rise to two different isomers which are called linkage isomers. Coordination isomerism arises when both anion and cation are coordination spheres and the ligands are mutually exchanged. That is coordination isomerism. Here it is linkage isomerism. The way in which the ligand is bonded with the central atom. When the connecting atom is changed without no change in the ligand as a whole, that is called linkage isomerism. It happens in the case of all ambident ligands like NO2 group, cyano group. It can be cyano or isocyano. Then thiocyanate, isothiocyanate, etc. Okay, so here it is the linkage isomerism, linkage isomerism for question number 107. Now question number 108, some ores are given. Which of the following is not an ore of iron? Which ore is not that of iron? Which ores are given? MgCO3, magnesite. See, remember magnesite is MgCO3, an ore of magnesium. So the very first one is expected to be the answer. A is expected to be the answer. Then hematite Fe2O3. Then magnetite Fe3O4. Okay, a ferromagnetic substance. That's why it is called magnetite. Then siderite, ferrous carbonate, not ferric carbonate, ferrous carbonate FeCO3. And lastly, iron pyritis or iron persulfide FeS2. Fool's gold in solid state. Due to metal deficiency defect, it shines like gold and is so called, when it is available in the ore form, it has a shining and it is called fool's gold, if you remember. Okay, iron pyritis. So our answer for this question 108 is A, magnesite, because it is not an ore of iron. Don't get confused between magnetite and magnesite. Magnesite is ore of magnesium. Magnetite is ore of iron. Okay. Now question number 109. This is from coordination chemistry. The overall complex dissociation constant for CrH2O6 times 3 plus ion is 5 into 10 to the minus 12. The overall stability constant of the complex. If you remember, overall stability constant and overall dissociation constant are related as one is the inverse of the other. Stability and dissociation. These are two opposite concepts. So, if one is given and the other is asked, you simply have to take the inverse to get the answer. So, here overall stability constant is 1 by overall dissociation constant or ionization constant, which is 1 by 5 into 10 to the minus 12. That is 2 into 10 to the power 11 among the given answers. 109. D is the answer. 109 answer is D. Okay. Now the last question we missed, 110. It is a cross the match the following type, matrix type. We will see. Here I have written the result only, not the question. See, on the left column you had alkane, alicyclic compound, benzenoid aromatic, non-benzenoid aromatic and a heterocyclic compound. And on the other side you are given with a set of options. Here I have already cross-matched them. The result is there. Look, among the given options on the right hand side, alkane. There was only one alkane in the given set. It was isobutane or 2-methyl propane. So that was cross-matched with the alkane. Isobutane was cross-matched with the alkane. Next one, alicyclic compound. Alicyclic means it is cyclic but behaves like a alkane, alkene, alkyne, etc. No aromatic nature. That's the meaning of aromatic and alicyclic. Different that both are cyclic. The similarities both are cyclic, but one is having aromatic character, other is not having aromatic character. So alicyclic, among the given answers, among the given options, the only one possibility is cyclohexane. Okay. Now we have benzenoid aromatic. Benzenoid means aromatic means it is not only aromatic but it is having a benzene structure. Among the remaining options, only one is having benzene structure, that was phenol. So we cross-matched it with a phenol. Phenol and benzenoid aromatic were matched. Now non-benzenoid aromatic. Non-benzenoid aromatic. Actually, the two remaining options were tropalone. It is not familiar to us from our textbook. Tropalone is a seven-sided ring. Okay, it is having a carbonyl group as well as an OH group attached to the ring. Okay, but apparently there are 6 electrons in the ring, but it is not cyclically conjugated as of now, isn't it? It is not cyclically conjugated, so we cannot expect aromatic based on this structure. But it has a resonance structure that, look there, this carbon is having a positive charge, means that carbon is having an empty orbital, and making use of this empty orbital, this pi electron system can delocalize, covering the ring as a whole. That makes it aromatic because it is cyclically delocalized, and the number of such a cyclically delocalized electron is 6, 4n plus 2 number. So even though by this structure its aromatic nature cannot be explained, its a resonance structure explains why and how it is aromatic. So this is an example of a non-benzenoid aromatic. It is not having a structure similar to benzene. Basically because it is having 7 sides on the carbon ring, but it is aromatic. So propalone is the example for, or the cross-matching for non-benzenoid aromatic. And finally we have another non-benzenoid aromatic. If we match non-benzenoid aromatic with this compound, furan, it is called furan. then we will not have a cross combination for heterocyclic. So sometimes we have to make modification. So even though both these are non-benzene aromatic, we cannot match this with the non-benzene aromatic, because then we will not have a heterocyclic compound. This is not a heterocyclic compound. It is a carbocyclic or homocyclic compound. So you can, for non-benzene aromatic, you can cross match only propalone, so that this is also aromatic. 2 electron, 4 electron, and the lone pair of oxygen together make 6 electron. So this is also aromatic. It is called a furan. So it is an example of a heterocyclic compound because it's a ring in addition to carbon containing one oxygen atom. So that combination is the correct perfect cross match. It is B in the given options. Okay. Now we really finished the discussion of this question paper. Take care. Bye.